Welcome to the Node Guardians podcast, where we discuss all things blockchain, decentralized systems, smart contract programming, cryptography, and magic's words. We're getting the second season started today on the channel, and as usual, we're in good company. Today in San Francisco with my friend David Wong. I am very happy to have you on the show. How are you?
I'm the first guest.
For the season 2, you're the first guest.
Very happy to be here then.
Yeah, and there's that funny thing. We're recording that both of us are French native, but we're recording this in English for the sake of making this episode as universal as possible.
Right.
So it's always an awkward exercise to speak with a fellow French.
We could have just paid someone to dub it,
Yeah, but that would I don't know. It would break some kind. Yeah, it would be less fun, right? So people are gonna enjoy some French accent, right?
Yeah, and we can dub that in Spanish for the Spanish audience after.
Yeah. So every time I get to, I think it's the third show that I'm recording with you, and every time I get to chat with you, you're up to something new. So for people who are not familiar with you, it would be nice to have some more context. If you could give us a little bit more information about your background, what you were doing, and what you're currently doing in a succinct way, and then we'll take some components of your answer and dive further into them.
All right, in a succinct way. Do I need to be zero knowledge also, or
do
I need to be intelligible?
So we're gonna play the game
with
the bad puns and stuff like that. All right.
So who am I in a succinct way? I always have a hard time answering that question, but I used to be an auditor, and I used to do pen tests, security pen tests, specifically on cryptography applications. Not cryptocurrency, but cryptography. That's how I started. I was the security lead for the Libra projects at some point in history, which became DM and doesn't really exist anymore. Rest in peace. And I, at the same time, I actually wrote a book called Real World Cryptography, which is maybe one of the way people know me. And after that, I actually worked on the Mina cryptocurrency from O1 Labs. And these days, I'm doing something new, and I'm doing a ZK pen testing at a firm called ZKSecurity. And that's, I think, my succinct summary of who I am.
Fantastic. So ZK Security, it's a very straightforward name. So you guys specialize into auditing ZK circuits and building tooling to be able to assess or find the threats in these circuits in a more efficient manner and understand them better. We'll dive a little bit further later and circumscribe and all this good stuff that you've been talking about on your blog. But before we get back to this, I'll be very curious to know more about how you figured out that cryptography is the road you want to follow, from your academia days, probably studying mathematics. What was the inflection, the turning point that got you to dedicate your time to this field?
So my turning point was, I guess, Dan Bonnet. I don't know how many people can relate with that, but Dan Bonnet was kind of the source of me switching to cryptography back in the days. More specifically, I guess I was studying math, and I was sort of miserable studying math because math is hard and it was theoretical math, so nothing applied, and you just have to deal with a lot of very abstract concepts, and it wasn't really my thing or what I really enjoy doing. And so one summer, I guess at the end of my bachelor, I was working at McDonald's, and during my breaks or during my off days, I would go to the library and I would study this course on Coursera called Cryptography 1. And I think a lot of people know Dan Bonnet through that course. And that was my first introduction to Dan Bonnet as well. I think it was the first year of Coursera. So it was really pure luck. If I had been in this position a year before that, I don't know what I would have done with my life, But at this point, I was ripe to change what I was doing because I was finishing my bachelor, going into a master's. Dan Bonnet was here for me in between McDonald's breaks, and that's pretty much how I got into this amazing field. Yeah.
All right. And so now you're pretty much living off your passion. You are auditing ZK circuits, you're still in security, and you're offering a solution, an auditing solution for anyone that's building a ZK app, a ZK circuit, and you provide some kind of consulting on whether this is safe or not. I also had another question in regards to the working culture, because you've had a few hops. You were at NCC Group,
right? NCC Group,
yeah. Which is a broader security firm that does pen testing and security research in various fields, even in retail applications. I would, or maybe not.
Yeah, I don't know. At some point I thought it was the biggest pen testing firm in the wall, but I'm not sure if that's true or if it was true or if it's true now or anything like that.
It's good to say when you work there, but once you're done with it, like, like
yeah, I don't know. Like I know they have a lot of employees and they have offices around the world and they do like all sorts of like consulting. They do like hardware. We had a crypto services, which is where I used to work. They have like red teaming, like they show up at in offices and try to like follow people, tailgate people to get in and use code hangers to like open doors. And so when I used to work there, I would hear stories at lunch from all sorts of like people doing different things, from web app pen testing and to like red teaming. And so I never really understood how big we were and exactly what we were doing. And we do also like investigation forensics for like, I don't know, the Dutch government, like stuff like that. It was a pretty big thing. And my thing there was pretty small. It was the crypto services. I think I was the first intern there when I started, and nowadays it sort of like became a success story, and the team grew multiple times the size of what it was at the day back then.
Yeah, and then you joined Facebook's initiative to design a blockchain-based network, if I'm not mistaken, Libra and DM.
Yeah.
And you were leading security at Libra. What's the difference that you would, like in terms of working culture, what was the difference in terms of flow and approach to work that you've observed after working for O1 Labs, which is one of the main contributors to the MENA protocol, and working at Facebook? Are there like some key differences you could?
Yeah, I'd say my life as a worker has been kind of hard because like every time I've changed jobs, I've also changed role. Like I used to be a consultant, and as a consultant, like you get trained to be good at specific things that don't necessarily translate to other fields. Then I changed to work in a security team, which is like something like totally different, and you get all sorts of responsibilities which you don't have as a consultant. As a consultant, you do a job for like a week or 2 weeks, and it doesn't matter what happens, it's behind you after, right? Maybe there's like bugs to fix, or maybe it was a nightmare. It doesn't matter because you're out of the project at the end, and it's not your problem to like deal with and whatever. But when you're working on a security team, then everything becomes your problem. You really get a sense of pressure and stress, and like basically if something breaks, it's like sort of your responsibility. Not only mine, but like as the security lead, it looks pretty bad if I miss something, or so you start being self-conscious about these kind of like you can be everywhere, but you need to be everywhere, and you're always thinking about the security of the product. And this is more of this is completely different kind of role that I had to play. And O1 Labs was again a different role for me. It was more development and research, and then I became an architect in the middle of it. And there I had to sort of like switch gears again. And I don't know how many people can relate with that actually, but I think that's interesting, so I'll say that. I don't know. I'm going on a tangent here, but I think it's interesting. Like when you're in school, you never learn to like finish a project. The project always stops when the exam comes, and you do like you do fine on the exam, or you don't do fine, or you pass, or like whatever, or you do great. But once you did that, you don't need to study anymore, and you can move on, right? And maybe in some subjects you do great, in some subjects you don't do great. But when you're a developer, like if you don't do great, you cannot move on until the task is done. Until you understand how to make it work, nothing is done. So I feel like there's a lot of jobs that don't have this dimension, and there's some jobs that have it, which is that if you don't finish your work, you're stuck with it. And I think this is actually the best way to make progress in your life, is to have this kind of like ventures in your life where if you don't finish that project, if you run the compiler or like the test suite and it doesn't say that it works, then you cannot move on with your life. And if you have that, I think you can make a lot of progress in your life. So I don't know if that was interesting for people, but I think that's
It's like Japanese Kaizen for software development, basically.
What's Japanese Kaizen?
It's this notion where you have to. It's this notion of perfection that's very embedded in Japanese society, where you gotta do your best at your craft, otherwise you would shame your whole legacy and the whole bloodline, right? Everything is at stake, and you gotta excel in one path, and you always gotta iterate and do better for the good of everyone and everything that surrounds you, and also for yourself. At least that's my attempt at defining it. I apologize for any Japanese viewer if the concept hasn't been well represented, but Yeah, I understand that you take a high level of ownership when a code base is actually supposed to be audited and maintained by you, and then you end up in a war room at 4 a.m. because there is some kind of component that's broken, or there is some kind of 0-day breach that's exploited, and then all of the stuff that you built has to be patched real quick, or hundreds of millions of dollars are going to get siphoned.
Yeah. So from that point of view, being a consultant is actually a pretty nice position because you don't have all these responsibilities.
I mean, if you put your ZK security stamp on an audit and you
Right.
consider this like behind you and then it gets exploited, you're still a bit concerned, right? Because that's your brand that might be tainted.
True, but it's not like you build the thing, and like if you're a builder and you're like the main developer of a project, the amount of responsibilities that you have is and even like implicit responsibilities that you have to think about throughout your life. Like you're never on holidays, basically. You're always thinking about that. Once I'm done with some job as a consultant, usually it's behind me. I'm not gonna work more. I've charged these hours. Maybe I would have found a bug if I was charged for one more week. But at the end of the day, that's something I can live with more easily than being the main developer of a project and a bug comes and people lose like millions of dollars because of like a bug I introduced myself. So I find it easier to live.
You price by the day, not by the line of code.
Oh, sorry, what?
You price it by the day.
Oh, as a consultant,
not by the line of code.
Yeah, as a consultant, by the day, usually by the week, even. Oh, yeah.
Yeah. Okay.
And by the way, it doesn't mean I'm not doing a good job, right? But it means that it's easier to do my job because I don't have the sword of Damocles,
yeah.
Like swinging over my head, so I don't feel that, and I can focus on doing my job instead of sweating balls every day.
Yeah. It's maybe a better environment, a better background to maybe to have a better acumen, to be in a better condition to spot vulnerabilities. It's not very an elegant way to say it, but I think you get the point. There's one thing. So you have a lot of crowd-based auditing platform. I'll call them like this, like Immunify or Code Arena, that have boundaries listed and that are securing some protocols that we use in Web3. Let's put it this way. In the field of ZK, I was wondering if your proficiency at being an auditor of circum circuits or whatever, noir circuits or anything is bound to your raw mathematic ability. That's one thing that I was curious about, and it's always the same shit. You're like a programmer, a software engineer. You're curious about ZK. That's the new hype. We'll talk about the ZK hype a little bit later, and you go on that Telegram, and then someone from Lambda class or another great company is gonna tell you, yeah, no, but it's fine. Like you can get the gist of ZK by reading Moon Math. Here is a PDF, real world cryptography, this book on elliptic curve, and 5,000 pages from Justin Thaler. It's good, son. You can just read that, and you'll be up to date. It's just what you need to write circuits in a. Yeah. So I wanted to know what's the relationship between.
I'm not going to tell you that.
Your math, no, obviously, but I'm just like, it's just a meme. It's like you go on that Telegram group and you get the same recommendations, or on Twitter. What's the link between your ability to do, I don't know, like calculus or algebra or mathematics and auditing circuits? What's the relationship between these?
Yeah, I would say half of auditing circuit is just good old like pen testing, where you're going to do a good job based on the amount of hours or time you're willing to stare at the screen. And that's sort of my opinion, is that like good consultants or good pen testers are people who have the ability to stare at the screen longer than other people. And if you can stare at the screen longer, you're going to find bugs. It's just a matter of how long are you willing to stare at the screen, right? The other half of that is more math-based. Actually, the more low level you get, the more math there is, and the more... So depending on what you're trying to do with circuits, what you're trying to implement with circuits, you're going to run into field arithmetic and these kind of things. And this is where people start making error, right? Because people tend to forget that they're doing operations in a field, the circuit field. A circuit is instantiated over a field. And so sometimes you do big integer arithmetic or things like that.
Out of a field.
Which are in a different field, right? And so you need to like range constraint thing, and you need to like figure out if the limbs are computed correctly, and you need to do a lot of thinking like that. And so this is where it gets more math involved. I wouldn't say it's like the most complicated math. If you're auditing a proof system, you're going to deal with like more complicated math. The math that you run into auditing circuits, I think is more approachable for people who don't necessarily have a math background. I don't think it's like unrealistic to get there or even to get trained.
Yeah, we can talk about ZK DSLs. So you have like different frameworks, snarky.js, high-level languages to write circuits without like any understanding of the cryptography underlying it, like for instance, Leo, or I don't know, Cairo, the latest iteration of Cairo, Noir, sorry. And then you have the more low-level stuff like Cairo 0, for instance, where it was less intuitive. And so what you're basically saying is that if you're handling code base with a high-level language with a lot of abstraction that's very expressive and easy to read, then it's more up to your traditional ability as a pen tester or security researcher to find some patterns, some discrepancies or some vulnerabilities. But when you're handling with code bases written with more like low-level tools, you have to take into account constraints and elements that require you to have a good mathematical vision. I'll say it this way, right?
Yeah, I think that's a good way to like map what's happening. It's like you're always building on top of like frameworks or black boxes, and so if there's enough abstractions for you to use and not leaky abstractions, then you probably are gonna do a good. You're not gonna run into too much math or like complicated things to like write what you want to write, which is the ideal world, right? We want developers to write things without thinking about range checking everything or like thinking about the beats of all their integers, or like I don't know what questions people have to answer there, or problems people run into when they have to do these kind of things. You want developers to just use libraries and to have to be able to implement the ideas that they have easily without thinking too much about the low level stuff. But these boxes and abstractions have been built by other people, right? Or haven't been built. But if they've been built by other people, then when you look at that, then you can have more complex things to look at, different types of bugs, it's more involved. And then you keep opening black boxes and you end up at the proof systems. Right? So depending how deep you are in that stack, you're going to run into very complicated stuff.
Yeah. And ZK security, like it's not only just contracts or like ZK apps. Do you guys go beyond the scope of ZK apps and audit just systems?
Yeah, so I guess the thesis when we started was that we have a lot of ZK frameworks that are being launched or being developed. You gave some examples, and we think people are going to start applying these new tools to create applications, right? ZK apps, ZK applications. So the thesis was if the smart contract market has boomed, the ZK app market is going to boom as well, and we're going to have to audit a bunch of ZK applications, and we as ZK practitioners are going to be the best people to do it.
Voodoo specialists.
we're in a good position to like start this. The reality is that a lot of these projects haven't launched. People writing these apps don't necessarily have the funding or the envy to really get an audit at the moment, and so what we've seen for the most part are more like low level, either proof systems or people writing very low-level circuits specifically for L1s or these kind of things, but not like ZK apps based on like snarky.js or Leo or Cairo or Noir or these kind of things. We haven't seen that much stuff there.
And how do you streamline, ensure homogeneous quality for your services? The thesis and the statement on ZK Security website is that you guys specialize into auditing ZK circuits applications without setting boundaries on what language the circuit is written with, etc. So how do you ensure the same quality of auditing when dealing with languages and frameworks that have their own intricacies and that are sometimes structurally different? How can you offer similar guarantees when you know that you're likely to deal with things that are totally different and languages and stacks that are sometimes like the compiler and the languages and the syntax are still changing like every week sometimes.
Yeah. So it's sort of the reality of being a consultant. Like even like back then when I wasn't doing anything ZK, like I would audit cryptography applications and I would audit whatever language the people had used on that project, right? So actually for me it was kind of a crash course of a lot of languages. I went through like I've audited like Perl and Erlang and OCaml and PHP and Rust and all sorts of like crazy languages. I don't know which one was the craziest language that I've audited.
Haskell.
Probably Perl. I've never looked at Haskell actually, so that's one that I'm still missing in my list.
Do we jump to the formal verification hoax or actually I'll give you credit. No.
But the reality is that you always have like different platforms, different frameworks, different languages, and you sort of have to adapt to these kind of things. In ZK, I would say it's easy and not easy. Easy in a way that if you look at compilers, most of them follow the same sort of patterns. So when I look at, for example, ArcWorks has an R1CS library to write R1CS circuits, and Circom does the same thing basically with their own DSL. We like when you look at that, you know that basically the compiler is doing sort of the same thing. You can look at how they implemented constraints for different operations, common operations, and they might do it differently. But you quickly get a sense of like when you see a line of code how it gets translated into constraints and what's heavy, what's not heavy, and these kind of things. Sometimes you run into issues, especially with DSL, where you can't really. It's not super transparent. It's not like you're working with a library in your language where you can, click and see the implementation of something. With a DSL, it goes through a compiler, so you have to look at the compiler. So it's a bit more tricky sometimes to see what's happening. And I guess that's why we released that tool, Circumscribe, to sort of like see what's happening behind the curtain. But I would say for the most part, you get a feeling. And if you're curious, you should look at what's happening. As a consultant or a security consultant, I need to look at what's happening. So that's why I created that tool. But yeah, you get a feeling. The second part of the answer is sometimes things get more complicated. And so, for example, Cairo is different, right? They have, it's a VM, so they have their own instruction set, and things are going to be pretty different there. I would say that in these kind of situations, when we look at VMs, it should be easier because we sort of remove a number of ZK bugs because you don't really have to think about circuits anymore. Because now you're just thinking about normal instructions like you'd audit any other language that is compiled. So from that perspective, I really like the idea of VMs. I think this is something that's playing out right now. Like we look at different approaches to ZK. People are creating frameworks where you can write circuits. Snarky.js is one example, or Leo or Noir, right? And some other are looking for an approach where you have a VM and people write these programs in like a higher level language. And I like this approach. It's harder to write something efficient because you're sort of like, you have an abstraction in between you and the proof system. But I think you can also write less bugs. So it's a very interesting approach. And as proof systems are going to get more and more efficient, I think VMs are going to be more and more sexy.
Interesting take. I might have some questions in regards to this a little bit later, but I'd like to bounce back to the latest audit report that has been disclosed from ZK Security, and I believe it is the first one. You've audited Penumbra,
right,
which is a DEX with shielded pools and shielded the order book, if I'm not mistaken, by Henry de Valence and other amazing cryptographers. That uses a heavily modified Cosmos-based, I believe, with a lot of custom components. So props on this. Something that caught my attention is the way vulnerabilities were flagged in the report. It's like ZK Security was labeling some vulnerabilities as critical or severe or highly critical. And for instance, NCC would flag them as intermediary. What is there like a lead or an explanation to this discrepancy between the way threats are assessed between the two different entities?
Yeah, I got that a number of times. So it's actually interesting because for me, like these severities are actually not super useful. And I've actually asked my clients if they want me to remove severities from public reports. Because I think when I use severities, it's mostly a way to tell clients, you should fix that. You should probably fix that. And this you can ignore. Like usually it's like what you see in like big companies when you see like P0s and P1s and P2s. Like P0 is like priority 0. You need to fix that as soon as possible. Drop everything you're doing until this is fixed. P2s are like, you don't need to fix that. And that's basically why we have severities, right? It's supposed to be useful. It's supposed to be useful for the client, for them to like sort through the findings and like prioritize and these kind of things. For public reports, I don't think it's that useful, but Penumbra actually wanted us to put the severities, which I thought was pretty amazing. They were actually extremely transparent, which is, I guess I'm not used to these kind of clients coming from the Web2 world. But Penumbra was pretty amazing in a way they really wanted to share everything we were doing and very transparent there. And the other part of the answer, I would say, is also we don't have criticals. I decided that critical was kind of a buzz, like a buzzword and a kind of like a, hey guys, we found a critical kind of thing. So basically we only have highs, mediums, and lows and informational. NCC Group has criticals, but it's mostly like an artifact of history, I believe. If they'd have a serious conversation about that, maybe they would drop the critical. At the end of the day, we're not trying to scare anyone, right? We're just trying to like provide a useful metric to know if something needs to be fixed or not. And that's all there is.
No, interesting. I'll leave in the description the link to that report for people who are curious who want to know more about it. Another thing, and that's above my pay grade, but I'm just gonna give a comment, or at least my
Probably above my pay grade too. Then.
Yeah, but like my thoughts at first glance when I hear about formal verification. So I see a few formally verified contracts getting exploited lately. It can happen. It's not like the panacea, but after spending quite some time on Twitter and taking a look at how things are that have formal verification are promoted and how formal verification itself is promoted, I had that idea and I kind of started to think that it's some kind of trick to make things look more sophisticated and make your service look fancier than it actually is to maybe legitimate the service being more expensive. I just wanted to have your opinion on formal verification in the context of auditing. What's your take on this?
I like that you're saying that because actually it's funny because people have been asking me about formal verification a lot more these days. I guess, I don't know, I'm not aware of these reports. So I'm interested to see that. You should put a link of these things.
Yeah, I'll leave at least one of those. Yeah.
Yeah, maybe that's why people are talking more about these things. And I love your question. And by the way, I never asked you to ask me that, but I love that you just asked me that, or the way you said it also. Yeah, it's sort of this. To me, it's sort of this unspoken secret in the security consulting world. Way before ZK or in the security world, formal verification is this kind of like ideal that people pursue, but that has never really found anything. And so it's kind of a great way to like market your company or to get grants, government grants that are really good with formal verification. Some companies are basically built on formal verification grants. Allows you to hire very interesting people because these are very interesting problems to solve. So, very good people are attracted to that. And so you can hire this kind of a persona. But essentially as a consultant, I don't remember ever seeing anyone find a bug using formal verification. It's actually very involved to use these kind of tools. I've seen it being used also on projects by developers. And that I think is good because it's more of a long-term thing to do, to use these kind of tools and to write formal specs and things like that. So if you have the time to do it, I think it's a great exercise because it forces you to put your protocol into a different shape. And by doing that, you can find bugs. But I would think that most people doing that would find bugs by the exercise of writing these specs rather than pressing the button after writing these specs to run the formal verification tools so that and then they find a bug because there's the result is like, hey, there's a bug here. I don't really believe that these kind of things happen. And maybe they have happened in the past, but it's pretty rare, I would say. So as ZK Security is a consulting firm, we have to play the game and we have to talk the talk. So we release these kind of tools and we use them. And we just wrote a blog post about that. So we have to play a game, but we're never going to find bugs using these things, honestly. I don't really believe that.
So there's no solve-it-all framework to... Yeah, I mean, it's
gonna happen. I think at some point maybe AI are gonna be like clever enough to find some bugs that are gonna be interesting. But I think we're really not there yet. Right now, there's a lot of friction in using these tools.
I think that as large language models become more proficient, you can definitely not formally verify, but fuzz in all the ways and calculate all the symbolic execution path and all the kind of things, like simulate the thing in all the angles. You can probably leverage AI to assess the quality of some code or maybe the security of some code. But yeah, definitely we're not there yet. And
I hope I'm not gonna make too many people irritated with what I said on.
That's what you're here for.
Like, yeah, but that's my take. That's my take.
No worries. It's no big deal. And I wanted to ask you about. So lately, we've seen some of the large validity rollups and ZK rollups go down the Stark and Fry path. When I'm sticking to IPA, and okay, that was bad. And it seems that the
IP is not in frame, by the way. So.
But the Matter Labs recently announced that they're shifting to Starks. Polygon Hermes is using Starks. What else? Like a bunch of projects are turning towards Stark-based systems, Starknet, you name it. And I wanted to know what's your take on this? Is Stark like the I'm gonna use that spicy term, the endgame for.
Oh, no. I thought we said we're not using that
then,
word
then I'm going to
anymore.
use the term trustless. But is it, yeah, you've been like dabbling and messing around with proof systems. You've worked on Kimchi, you've audited probably other proof systems, etc. And I wanted to have your connoisseur take on this. Is it like the advent of Stark, since there's a consensus around this technology, or you believe that folding schemes can break the status quo and change the dynamics around this?
Okay, so yeah, it's interesting because so I'm not aware of like all the. I feel like there's a bubble of like a Stark bubble, and there's a lot of Stark things happening, and there's a bubble of like non-Stark things, and I don't know which bubble is bigger. I would say I'm in the bubble of the non-Stark side, and I don't know if we're in the right. If I'm in the right bubble, I don't know if I'm in the biggest bubble, but there's definitely two worlds, and you might see different things depending on where you stand. Yeah, how can I answer that? So from my point of view, I've seen things like that play out in the past. I've seen like wars of like signature algorithms with like ED 25519 and DJB like pushing for that a lot. I've seen wars of like hash functions with like SHA-3 and Blake 2 and different people wanting different things. Usually the fastest thing tends to win. And that's what we've seen in the past, or like the things that are free and not patented. But for proof systems, I think we're in the middle of it. I think, like you said, like every year there's something new coming up.
And you're kind. Every month.
every month, every week. I don't know what's the frequency. It's insane. It's really hard to follow. But yeah, like we're really in the middle of it, and I think we haven't seen the winner. If I would pick a side based on my experience, I would, and this is a spicy take. I would think that Starks don't have the brightest future. But I would preface that by saying that maybe it doesn't matter, because most of the time when you're trying to build a product, you shouldn't chase whatever is the best thing and always rewriting your stack from scratch and always like reinventing what you're trying to do. You need to make a bunch of design decisions and technological decisions. You need to like solidify them, and then you need to go with that. So whatever your stack is today, and if it's efficient enough for your application, I think it doesn't matter who's gonna win. You should just go with it and focus on building what you're doing. Okay, now that I've prefaced what I want to say, what I've seen in the past is that, for example, in signatures, there's signing schemes that are based on hash functions, hash-based signatures, and there's signing schemes that are based on discrete logarithm and these kind of problems. And you can quickly see that the one based on hash functions, or maybe they're post-quantum cryptography and all of this, but usually they can't get away with much. Like they have like large size keys or signatures, and they're more clumsy, and they take more to compute and so on. And so I think we're gonna see the same thing with Starks. I think because Starks tend to use like Fry and these kind of like polynomial commitment schemes that are hash based, and this is why they're post-quantum secure. Because they do that, they're limiting themselves in a lot of ways. And so they cannot really take advantage of a lot of the modern improvements that are more like math, like algebraic based. And so folding is like one of the big one, right? Folding schemes are like taking over the world of ZK right now. Not just that, there is also Lasso and Jolt that just came out, and that I think have like spicy takes on Starks like a lot in their.
Has it been I've been seeing some controversy around Lasso and Jolt just from afar, that it hasn't been in production. So it's all very theoretical, what is stated in the paper in terms of like the benefits and the performance improvements that it could lead to.
It's all very new. I mean, it's the same for folding. Like we're trying to like measure the performances, and different people, including us, are trying to like get implementations and see and compare. But I feel like just from a theory point of view, like it looks like the folding improvements or some of these lookup improvements with Lasso are things that are really gonna change the game. And it's annoying if you cannot do that. Like it's gonna be very annoying if you want to like push the limit of what you're doing in ZK, which most people want to, because ZK is still not the most performance primitive right now.
Okay, pretty cool. And among all the roll-ups, I was at BASS, Stanford Blockchain Conference, I believe. I was watching one of the keynotes had some kind of infographics where you had an analogy between the Cambrian explosion of proving schemes and a breakthrough in ZK proving systems and technology versus Moore's law, and that we're able to do things super fast, etc. And I wanted to have your opinion on creating a domain-specific language to optimize proof generation versus bearing with the abstractions and the implications that they have on developer experience, but also in performance, knowing that there's a future where proving will be faster because we've done a lot of optimizations. And it is inherently, naturally, a highly parallelizable job. Do you think that, as in like GPU acceleration field with CUDA and Metal, we'll still see a relevance for domain-specific languages that are optimized for proof generation? Or ultimately, at the end of the day, maybe ZKVM were that was the right path to follow, because we know that we won't really be bound by the performance of the prover in 5 years. And ultimately, what you want to offer is the possibility for developers to compose with languages that are more documented and tooled.
Yeah, I guess, I mean, yeah, computers are getting better. And if we wait, things are going to get better just by design, because we're going to get more memory, more computing power, and so on. I guess there's different things to unpack here. Like, there's the approach of like, do we want VMs, even though like there's like some abstraction that might prevent you from optimizing things? And I think I would say yes. Right now, things are not too performant, so we want to like handcraft a lot of these constraints. But I think with time, things are going to get so much more performant. And I think with folding, we're seeing that VMs are going to be kind of like the way, for ZK frameworks or these kind of things. Regarding, I don't know, there's also this question of like GPU acceleration or hardware acceleration. I've always found it odd to pursue these kind of things, knowing that proof systems are changing so much. Unless you have a proof system and you've like ossified yourself into a specific, set of parameters and like a proof system, and which is fine, which you need to do if you want to build an application, right? That's useful. In this case, then pursuing GPU acceleration or these kind of things to improve performance sounds like a great idea.
I was just referring to the fact that you're still incentivized to compose with frameworks like Metal or CUDA to get that 20% extra performance or 30% extra performance and leverage the hardware better, even in modern applications and games. While you could actually just dish that framework and build immediately and deal with 40 FPS less on most modern devices. But there's still an interest for people to use the latest framework to get more out of the hardware, even though it's just a 20% performance improvement. And I was just referring to the fact that it might be the same thing for ZK DSLs. And maybe there could be some business logics and use cases that would actually take advantage of the fact that language is more optimal in regards to generating proofs. That was more like the analogy that I was trying to propose here.
Are you saying that like in some situations you might take advantage of these GPU optimizations more easily? Or
No. The GPU optimization is actually an example that's been introduced to me by Ali Ben Sasson during a call, and I was asking him exactly the same question. And he said that even though GPUs are 100 times faster than what they used to be in the past, and I'm taking shortcuts abstracting what he exactly said. Excuse me, Ali, if it's not exactly what you said, but it's probably more or less accurate. GPUs are much faster than they used to be, but people are still using CUDA to get the best out of this GPU, even though it's just a slight improvement in performance, right? And so the point was that you might still be interested to build with Cairo, because it's optimized for proof generation, instead of going with the ZK VM, which might have some abstractions that could hinder its performances. And even though proving schemes and proving systems and become infinitely faster,
okay, I see.
you might still want to go with the ZK DSL to get that extra efficiency for your business logic.
Yeah, I would say, like, so imagine you're like a developer that doesn't know much about these things and you just want to write your ZK application. Like, you're going to want to use the thing that allows you to do that without having to deal with like low-level stuff or like seeking these kind of optimizations, right? And so I feel like this conversation should be like moot in a way that if we want like more and more developers to be able to access these tools and like write things that are useful for them, then we should make it so that they don't need to seek these optimizations. They don't need to like, they can write whatever and it'll run efficiently. And it'll, sort of like now people write like very inefficient things on their computers because their computers got so much better at doing things. People write like native app in Electron, and it's like the worst like offender in their like the native app world, but they can get away with it because computers have so much RAM and like whatever. So I would like ZK to get there, right? Like so efficient that people don't need to care about like all these like optimization seeking and like low level stuff. And does that make sense?
Yeah, no, that makes a lot of sense, and that's a The answer is accepted. It's valid. Thank
Right.
you.
I pass.
Pass. I'm not going to ask you for an alpha leak or disclose a vulnerability, because obviously you're not going to do that. You're bound to non-disclosure agreements and other kind of commitments. But in your career, there are probably some stories and some vulnerabilities that you uncovered for a customer that you won't give the name of. Isn't there some kind of fun tale you'd like to share with us? Some vulnerability that you found that was actually, that if exploited, could have led to the compromising, like, I don't know, billions of messages or dollars or something like that. Is it some kind of just an anecdote, even from your uni days? Doesn't matter, but I'll be very curious to hear something.
Yeah,
like
I guess I have a lot of fun stories.
One, the sharpest one.
The sharpest one, only one. All right. I mean the last stuff we published, I think, has like some of the most interesting vulns we found, and it was not running in prod, so everything was on a test net, so it was fine. I found some stuff. So I guess one of the first cryptocurrency that I audited back in the day had like this kind of like so like they would like hash. Basically, you have a transaction and you have to hash it to sign it. And they would hash the transaction, but they would just basically put all of the fields of the transaction within, they would just hash things like that and sign it. And basically, you have this kind of thing that's called an ambiguity attack, or this kind of, I don't know, for lack of a better name. And how to explain that? So someone would sign a transaction that would send me, let's say, $20 for like $1 of fee. And what I would do is that I would pretend that it was actually a transaction for 20, and I would move the 20 towards the $1 fee. So it would become like $201. It's not exactly that, but that's one way of understanding it. I would move the boundaries between things, and the fee would become zero. Basically, I would move the fee into the value. And so I think that was one of the most interesting vulnerability I found, like in a cryptocurrency, where I could just like arbitrarily change things in a transaction. The funny thing is that it took them a very long time to fix that, and that was kind of upsetting from my side. I was like, why are you running this and not fixing it? Well, anyway, if they're listening to this, I'm sorry, guys. I'm not gonna name
We don't know
anyone, but you should have fixed that sooner. And yeah, I think that's one of the most disturbing and interesting one.
Yeah, I think that it's pretty tricky, because I think that verifiable computation, validity proofs, ZK proofs open the door to, like, it's an avenue to a lot of use cases, and it can make a lot of things more virtuous, efficient, scalable, you name it, privacy ready, etc. But there's also this whole concept about trust minimized systems and trustless. And there's I'm excited about this technology, but it hasn't been in proper production with real value at stake for so long. And if I ask you today whether you would trust a certain cryptographic primitives or a proving scheme to lock like all of your net worth for the next 5 years, or some very personal data on top of a rollup that uses like Schmiblik, I don't know, proving scheme, or
Right.
potato polynomial commitment, would you have, because it relies on sound mathematics, pure mathematics, and great stuff, would at this stage, would you still say that, would you trust them with your ability to actually understand them at a deeper level?
Personally, I'm very paranoid, and even just like holding crypto in general is hard. Like things happen, and we've seen things happen a lot in the smart contract world and these kind of things. I'm always scared, and I don't know how to answer that. It's
No.
I'm very paranoid, and
Welcome to the club. Thank you.
and ZK is like another layer. The more complexity you throw at something, the more venues for bugs. So, but there's no other way, right? Like cryptography has become secure throughout history by just having people rolling their own cryptography and other people finding bugs and things improving slowly and gradually, and then we get at a point where we have great implementations for things, just for people to use to implement secure applications. But if you look at TLS and OpenSSL, things were quite the shit show for the longest time. And so even for let's say the most basic algorithms that surround us, we had huge issues. So I don't think ZK or like these kind of technologies are like an edge case. Like it's part of cryptography. There has been issues. There have been issues. There's gonna be issues. and we have to expect that. And I guess if I had an L1 and if I was running an L1, I probably would have a different, speech right now. I would try to.
Okay, you're not running an L1
Exactly,
anymore.
right? I would have to say, of course you can trust it and like whatever, but know that I'm not working for an L1. I can be my paranoid self and share my more nuanced take, I guess.
Unbounded opinion, like yeah, and I'm like that's interesting. That makes sense. Yeah, like in the whole landscape of like yeah, in the space, are there other fields or technologies that you're following closely? Like putting ZK aside.
Putting ZK aside.
Yeah. Oh yeah, okay, you can stick to ZK. Okay, I'm gonna make
I was
it
going to
easier.
tell you about Counter-Strike 2 that's coming out.
Yeah, no, please.
If we're talking about ZK, like I've been folding and like Lasso and Jolt and stuff like that. Besides ZK, I think MPC's changing also. Like it's kind of weird because like I'm in the ZK bubble, and so by doing that, I'm sort of ignoring the MPC bubble. There's an FHE bubble. I don't know what's going on there. It might go. It might be like I don't want to say anything, but FHE has been like completely out of the picture for the longest time. So I'm curious if it's still the case or if the bubble is actually growing in size for good reasons. I'd be curious. But the MPC bubble, I think, is growing for good reasons. I think things are changing there. Things are becoming more and more practical, and actually we see products that are using MPC more and more. So that is interesting and something I should personally pay more attention to, and I think people should pay more attention to as well. I think blockchain-wise also that there's some interesting things that people are not really following. Like I feel like all the buzz is around.
Are you gonna shield Narwhal and Bullshark or the
maybe yeah. All right. I'll just mention that.
I'm kidding. Just go ahead.
Like I think it's interesting. People are always talking about Ethereum and L2s on Ethereum or Bitcoin, but there are some really interesting, like more novel protocols out there, and Narwhal and Tusk, and I think FastPay is one of the more interesting one to me. So like, actually, I don't know who exactly was like started the FastPay thing. I think it was George Danezis and Mathieu Baudet at Facebook when we were working on Libra. There might have been other people.
Left there is.
All right, maybe we should get the reference. I apologize in advance. But that paper was fantastic to me because it basically like it started saying we actually don't need consensus for payments. And if we don't use consensus for payments, we can basically scale throughput like there is no tomorrow. And TPS doesn't even become a metric that's useful anymore. Like people are fighting on like 100 TPS, 1,000 TPS and things like that. No, you look at FastPay and basically you can have as many TPS as you want. It's just a problem of like throwing more computing power to the mix. And so who has adopted FastPay today? So Mathieu Baudet has a startup. I think it's called Linera. It just changed name, so hopefully I'm not making a mistake. I think Sway is using it also.
FastPay?
Yeah. I'm not sure how they're calling it. I think they changed the name. And I'm not sure exactly how they implemented that, but I think they have kind of like a sidechain where things are faster, but you cannot have like this total ordering between...
The causal ordering and the concurrency and like the fact that you can... I think it's if an object has a single owner in Sui, like an account,
right?
Whatever alters this object, it's fine. It doesn't need the consensus from the
Exactly.
However, if an object is mutually owned, a contract, then it goes through consensus.
Right. So that's exactly where they use FastPay. If
and
there's
it
one owner,
it was Alberto Sonino. I just did the reference checking.
Nice,
yes.
nice thing.
Yeah.
Sorry, Alberto. And he's great also. I think he's behind Narwhal and Tusk and Bullshark. But yeah, so Sway is using it for that path. When you're just doing these kind of like applications like transactions or like single ownership. And I believe Aptos is also moving or like adding support for that as well. So to me, there's like these 3 chains doing that. And I don't know why more people are not doing this because, yeah, this is kind of like the answer to the criticism that cryptocurrencies are too slow and Visa is doing I don't know how many transactions per day and cryptocurrencies cannot do that. Yeah, they can do that. And we have these protocols.
I remember having a conversation with Adrian Brink, who was working on a protocol called Anoma and who worked a lot on Tendermint. And he told me that even with Tendermint, you could actually, if you just optimize a Cosmos SDK-based chain with Tendermint to just do trivial payments, you can actually get dozens of thousands of transactions per second. And you should make a cluster of 10 machines or 20 machines. You can definitely get like the the flagship number that we like to see thousands of transactions, etc. I mean, like, we can extend the conversation on actually having a proper benchmarking framework for blockchain performance, because there's always a big gap between what academia and what you find on Arxiv states and the reality when you're like in the trenches during the testnet and you see that at 2,000 transactions per second, the network is dead. But it says on the paper 160,000 or 500,000.
Or Solana counting consensus transactions in their TPS.
I mean, at least they're achieving something, but I understand where you come from, and that's misleading to some extent, of course. But yeah, I could only hope for a methodology and a standard to benchmark systems in the fairest way and most coherent way as possible. I think Aptos has pushed something on that matter.
Right.
But there are a lot of intricacies and system-specific constraints that make that a universal standard for benchmarking still not so fair, because there's always, each blockchain has its own story and its own parameters that make it very hard to reproduce a context that aligns it with another competing system. But
back in the days, maybe not that long ago, like Ethereum had like huge problems and the network was saturated. Gas fees were like through the roof. It happened several times, right? And when that happened, people moved chain, right? Like people moved to like Avalanche, or people moved to like different things to see what else could like serve whatever needs they had. And if we were like in the ideal world, I mean, for crypto, maybe not for me, or for like depending on who you are, but the ideal world of crypto is that a lot of chains are being used to their maximum capacity, not being ghost chains. And so here we would like directly see what chain can handle the traffic, what chain cannot handle the traffic. And so that spicy take again.
I agree with you, and that gives even more legitimacy. Like, this is the scenario where block space is not abundant and everything is bloated because people actually have things to do on chain, either whether it is farming their favorite Ponzi or playing a EVE Online fork that is actually very addictive. You never know what could basically get these things started. But
there's an EVE Online fork.
No, I'm just composing. I'm GPTing my way through. I'm just dropping some words and
hallucinating.
But actually, CCP Games, the company behind EVE Online, has been funded by 16Z to work on a blockchain on a game.
I mean, they have a token, right? I mean, they have a non-crypto token, and people are going crazy over that. So
but now they're exploring some kind of blockchain-based kind of game. I don't have more info, so I haven't read enough. But yeah. Oh, just one last question in regards to the ZK security team. It's a team, so who else are you working with?
So I'm just a co-founder. We're a team of 3 co-founders. So there's Gregor and Brendan. So my 2 ex-coworkers working at O1. Brendan is the CTO of O1 Labs actually at the moment. And Gregor is the lead for the Snarky.js framework. So that's the 3 of us. We have some partnerships, but we're actually looking. So we have contractors and like people we closely work with. But we're actually looking for new hires and interns and these kind of things. So maybe it's a good moment for me to shout it out.
Yeah, please go ahead.
If you're interested in working in that space, doing cool research and finding bugs and having time to basically learn and impact the field at your pace, then you should probably shoot me a message. We're actively looking to increase the size of the team.
Okay, pretty cool. And one last advice for, I guess, anyone who wants to get involved in the space, or maybe like these questions are always tricky. So if you're not inspired, just one tip, one takeaway from your whereabouts, your journey in the space.
Read my book. Buy my book at the full price. No. But I don't know. Maybe that's it's kind of a biased. I'm too biased to say that, but I wrote that book for the me of the past that was struggling to learn cryptography, and I wrote everything that I wish I could have taught myself if I was traveling through time. So that's my best advice. But maybe you should trust someone else because I'm biased there.
If you're a solver on Node Guardians, level 3 or 4, starting from there, and you just post a comment, the 5 first comments from solvers will receive a digital copy of that book, and let's do it. We love our community, and if you're a solver, just drop a comment, 5 first comment with a proof of ownership of the account, of the solver account. Will receive the book from us. So I'll leave also all the relevant links in the description, how to engage with ZK Security, how to connect with David. And yeah, if you have any question, feel free to ask them, to join us on Discord, and I'll see you pretty soon for another episode. David, it's been a pleasure having you on the show. And
Pleasure was mine. Yeah.
Great.